Today we're going to speak about new technology and a new sensor in leakage detection. My name is Oscar De Vita, and I work for GVZ as a business development director. GVZ is a company that is dealing with sensors since almost the last 50 years. Today, in short, we will see the main reason why to choose a refrigerant leakage detector. We will introduce one of the latest technology, and I would say also interesting technology, developed by the US-based company Nevada Nano. And then we will jump into our latest detector that is using this new technology. Let's say at the beginning which one are the reasons mainly. We can say that there are two big groups of reasons. One is related to ethical reasons and safety, and the other one is more related to money motivations. On the environmental side, we can say that, of course, the reduction of the emission of unfriendly gas in the atmosphere is always welcome. Then we have to respect the rules. And last but not least, safety is one of the most important topics if we are speaking about flammable refrigerants. But let's say that also on the economics, if I monitor a system and I grant that it works always at the perfect point, then I can save money in maintenance and in repair costs, in the efficiency, because the energy consumption is lower, and the lifespan of the system is well. All this said brings to a high quality and reliable products, and at the end, it means improve the business of a company. We mentioned about regulations and standard. And let's say that recently with the introduction of the new refrigerants, the standards are driving the manufacturer to look with attention at the refrigerant leakages. And this brings into the market, develop new professional and also mass production technologies and sensor for leaks detection that has to comply with the standards. We have a portfolio since many years of modules, sensor and detectors based on the semiconductor technology, a well-known technology with advantages, but also disadvantages. Therefore, we recently developed our latest detector. I will tell you more in a while. First, I want to introduce you the technology that is the heart of the detector. Has been developed by Nevada Nano. Few words about Nevada Nano. Almost 20 years ago, they started studying and inventing technologies based on-chip chemical analysis. Their target was to create a sensor dedicated to the US defense, able to detect flammables in a reliable and in a long-life way, and also able to understand which type of gas flammable is in the air. Let's say that recently, almost 5 years ago, Nevada Nano has been authorized to put this technology on the market. So they developed three main family. One for flammable that is starting exactly from the original studies. A second one dedicated and focused on methane. And the third one that is growing every 6 months actually, dedicated to refrigerants, A2L and A3 refrigerants. And it took to Nevada Nano almost 6 months to put a new refrigerants in the library. So it's a process that is still ongoing. How does it work, the technology? In few words, there is a MEMS transducer. So it's a micro machine membrane that has a heater and has a thermometer inside, and it makes a sort of spectrometry of the mixture of gas. It measures the thermodynamical property of the mixture of gas, and the thermal property of a gas are determined not only by the concentration, but also by other factors like temperature, humidity, and pressure. And for this reason, inside the sensor, there are 3 other sensors for temperature, humidity, and pressure. And this means that the sensor is, that the readings is able to have a wide range of temperature because the reading is compensated by the 3 physics quantities that we said before. The measurement, because it's physical and not chemical, allow the sensing element to never wear and also to be poisoned by the substances. This gives the opportunity to have a long life sensor. We are speaking about 15 plus years of expected life. And because also there is no drift in the reading over the year, there is no need of calibration for the whole life of the sensor. Because it's on chip and the size of the chip is a square by 1 millimeter side, there is a low power consumption. And on the other side, you have to say that the cost of the sensor are high. Let's have a small comparison between this technology and the other technologies that are available on the market. So here in this table, you see the MPS technology. MPS, because of the property mentioned before, stands for molecular property spectrometer. That's the way how Nevada Nano wants to recognize this technology. In the comparison, you see here infrared, semiconductor, electrochemical, and catalytic. Let's say the mostly used technologies for refrigerant detection. To be honest, on the market we are facing nowadays also new technologies coming up, like thermal conductivities and speed of sounds in some sensor, but I had no data enough to put in the comparison here. Quickly, you see, MPS is not the best solution for cost reasons and also for the lower detection limit. It's not a technology that's good to be used for ppm or ppb concentration. It starts reading from a range of, let's say, 3% LFL or 400 ppm. And the task is to check concentration closest to the dangerousness, not to the micro leakages. On the positive aspects, as we said before, long life, maintenance-free, calibration-free, and the wide range of operating temperature. Speaking about technical performances of the technologies in comparisons with the other, here you see a report done by the Institute in US for the Air Conditioning, Heating and Refrigeration Technology, the ARTI, with the report indicated over there, done in 2020, they put together all the technologies available on the market at that time, testing with 28 different processes, and at the end, the results is that only one technology was able to pass the 100% of the tests that they made in US. And this technology is the MPS. So, said this, we went in touch with the Nevada Nano, we knew this technology, and then we developed a detector based on this. We call it MLD, the name is for molecular leakage detectors, and we want to bring and recall in the name the technology that is inside. So we create a family, a platform or detectors that is able to go with different refrigerants, A1, A2L, and A3. The lifetime and the working temperature are the one coming from the sensor, so the positive. The sensor is been mounted on a board with a micro and close everything in a watertight case. So the IP grade is 65. The detector has 4 output, so the communication can be done via Modbus, can be done via two analog languages, current and in voltage, but there are also two relays, one for the low and one for the high concentration. Both of them are programmable. Both also the sensor and our micro, the board, has been developed with built-in diagnostic software and watchdogs to control each other in order to give fault alarm, and as we will see later on, to be compliant with the safety rules like the seal level. Accuracy and response time are the one requested by the rules, so ESC and UL 60335-40. Active compensations, cross sensitivity, and poisoning are the features that are coming from the sensor itself that we mentioned before. For the certification side point of view, side to the seal, also ATEX. The detector is also ATEX certified. Last point I want to mention is that we put a lot of attention on the low environment impact that the production of this detector could have. Therefore, we asked to an Italian company that is dealing with a university to make the calculation for the whole raw material chain, supply chain. So the detector has been deployed in a single raw material for each component. So from the extraction from the mine to all the processes afterwards, and the transportation and the final assembly, all these put together brought to a result that for every MLD we manufacture, there is 1.6 kilogram of CO2 produced. This, and then we highlighted this. So the application are the standard application that goes from end-of-line production test bench to the closed cabinet for a chiller to cold room, so wide and closed areas. Let's say we launched the detector this year, beginning of this year, and we are happy to have been here in Cilventa launching officially. And I have also to say with the positive comments and feedbacks coming from the visitors. Now, if you want, I'm available for any question here, but also for sure, you are invited in our booth in the Pavilion 5. So thanks you all for your attention and looking forward to see you at our booth.